Okay, well, welcome. My name is Søren Manicus. I'm a co-founder of Indesmatech. I'm here together with Patrick Sienfors, who's my colleague in Sweden, runs Sweden and Norway for us. And we've been invited to give a short introduction on how we see LoRa and Lorawan is developing with some various use cases for the Sense1 event held by Sensative. So just a very quick introduction to our company. We are a technology and advisory company working on basically three different business areas. One is that we work as an agent for the semiconductor suppliers, and we are the representative for Semtech, who invented the LoRa technology, and hence, obviously a key partner for the LoRa and LoRaWAN technologies. We also do consultancy services on R&D and system solutions and business development. In other words, to help implementing the technologies that we have on chip level to help them implement them on system level. And finally, we run a web shop where we can actually sell the devices. We have focus on three different technology areas: wireless IoT, embedded computing, and audio and sensing. And we are a team of 14 people in Northern Europe. And just to make a quick jump, if you look on our web shop that we run, it's called lorawan-webshop.com. We have all different kind of gateways. We have different kind of applications that can be supported. We have all different kind of end devices that we can support. And for example, even the sensitive strips, they are on our web shop so that you can buy them here. And we have a tech support team that helps basically end-to-end implementation of solutions based on these technologies. So if you have any tech support questions, you can basically just directly communicate to our tech support team from this page to help with all different kind of programming issues, configuration issues, stability issues, and so on. Just coming back to a little bit more about how we see this market is developing. Now, first of all, and most importantly, why LoRa is so good for IoT applications is simply because of the long range using very low power for the device. Obviously, as you may know, LoRa runs within the ISM bands, which for our region is 868 megahertz. And the transmission power is limited to 25 milliwatts, and still you obtain incredibly long ranges. So this is an example from a live demo in Denmark. So some of you may recognize the geography of Denmark with Copenhagen over here. And basically what we did here was that we were driving in my car using a field tester to actually get some real data, live data while transmitting. And it's a small handheld device that looks like this, seen on my camera. And every time you press the button, you get a transmission, and you can see that actually driving on this bridge, you could see that one transmission was actually received by 7 gateways. And you see the list of here, and for those of you who have the technical knowledge, you see that it's even pretty good RSSI and SNR signals. And the signal was received at gateways up to 100 kilometers away. So this is, one of the key reasons why LoRa has become so popular for IoT applications, simply because you can obtain such a long transmission range with such a small output power from your device. So hence your battery will last for years on your device, obviously depending on how often you transmit. So some of the use cases that we have seen, and some that we are primarily going to talk about today, is about installations at municipalities. And this is simply because LoRa has been one of the preferred technologies used for municipalities when they want to make an IoT installation or become a smart city. This is really a buzzword around the globe that in the aim of digitalization of all different kind of services, you want to become a smart city as a municipality to collect all different kind of data, make it all available on an open platform to basically everyone, to make all services digitalized, and also, obviously make your city even more green. So this is from Aarhus, which is the second largest municipality in Denmark. This is actually now 4 years old when the municipality decided to start their smart city implementation. So it's 350,000 people. It's 470 square kilometers. And they could basically make a complete coverage of the area with 18 of the so-called gateways that is used to build an infrastructure. We'll just come back to that in a little more detail. But what is even more importantly is the cost to doing this, which was basically just 200,000 euros. So in other words, you can get a very good smart city implementation at a very low cost and basically get a return on investment, which is incredibly fast. Another use case we've been seeing, this is actually pictures from Switzerland, but it could have been locally, even also in Aarhus, is to get data from from the district heating supply, where you have pumps in 2 meters down underground, and you want to monitor the temperature and the humidity to have predictive maintenance on the pumps to actually monitor when you when you may need to go and do some services on this. And in the past, you would do this with so-called FSK radio signals, and each of the red dots shows where you would need repeaters to be able to collect the data. Changing to LoRa, you would actually obtain, or what was obtained with real life data here is that you obtained a diameter from the gateway, obtaining signals from 2 meters below the ground of 1.4 kilometers. So eliminating all the red dots for repeating the signals from former FSK. So just the price reduction from avoiding having all these repeaters makes your cost of service to run this use case significantly lower. The third example we have is also from a municipality here in Denmark, from the municipality of Ballerup. They wanted to make fleet tracking, so they actually wanted to have real live data on all devices that can move. So these are cars, lawn movers, trailers, whatever you have as a municipality. They decided to do this with Lorawan. The cost of making the Lorawan network installation was 50k euros for them. Installing 160 trackers on all their devices was another 20,000 euros. And after 6 months, they actually saved 10 cars they could give back to the leasing company for the simple reason that they could come to the conclusion that they were not needed in the infrastructure. So the return on investment on this full Lorawan installation was, just done on this one single application. And similar, if you want to do in-house installations, LoRa is very, very suitable for long transmission ranges within the building. Now, some of you may have been out installing Wi-Fi in buildings and knowing how many hotspots you will need to actually get a proper coverage. Well, noting that with Wi-Fi you get much higher bandwidth that you can obtain on IoT applications. But still, just as a great example here, a good example is we went to a hospital in Denmark. We installed one gateway to collect data from the sensors on the rooftop here, and we walked around the entire hospital, and we could monitor signals regardless of where we were, even 2 floors below ground, even all the way out here. We still had very good signal strength on the signals, and all the way out here. There was just one place where we did not have a signal, and we realized that that was because we were just having the radiologic department, I think it's called in English, between us and the gateway. And then for obvious reasons, that is quite dead from radio signals. Moving on, one of the very strong benefits from using LoRa is that everything is open source. It's the one and only IoT technology out there that is truly open source from end to end, which means that at each different levels, all the way from the chip to the modules, to the sensors, to the gateways, to the network service and application service, you can make your own decision of either buying ready available products in the market or develop everything by yourself. This is good and bad. The good thing is that you always have the possibility to go to another supplier or do it yourself if you believe that whatever service you are buying is not at the level that you were expecting. And compare that with your mobile phone. You're pretty much stuck to an operator once you bought your mobile phone. So it's not that easy to make your own 5G infrastructure if that's what you wanted. Here you can do it yourself, which is the good thing. The bad thing is that it's very, very challenging to run a business within this area, because obviously you cannot lock your customers to a certain service over a certain period of time. Again, because they can just go elsewhere and buy their services. And for example, on the network server, you also see from a Swedish perspective that you have the options both of Netmore and Yu-Gi-Oh to run your network server locally in Sweden. CB Commons is Denmark. The Things industry is pan-European. So one of the big trends that we've seen over the last, I would say, year is that if you look at the LoRaWAN infrastructure, looking at the traditional landscape, what we're seeing here is the end nodes that are, collecting a certain specific piece of data that you have built that for, whenever that is pet tracking, smoke alarms, water meters, trash containers, and so on. They transmit to LoRa gateways that are the base stations that picks up the LoRa modulated signal and transfers that either on a 4G, 5G, or Ethernet backhaul to a LoRaWAN network server. So the gateways basically translate the LoRa modulated signal into an IP signal. And then you host the network server, either, for example, from a sensitive point of view for the Yu-Gi-Oh platform, you host that either locally or on a cloud-based server solution. And this one monitors the network, whereas the actual data, the payload that is being sent from the sensors, is being transferred to the application servers. And the application service is pretty much where you present the data, where you make your decisions on what kind of actions are needed as a result of what is monitored from the devices. And everything is fully secured by double 128-bit AES encryptions. So you have one encryption key for the control signal for the LoRaWAN network, and then you have one security key for the actual payload, for the actual data that is being transmitted. And this is seen as being a very high, not highest, but high security level, specifically for IoT. And just as a side note as well, everything is bidirectional. So if your application server wanted to push a message down to the device, either as a control signal to a certain event or to do any kind of confirmations or firmware updates, everything is bidirectional. One of the key trends that we've seen over the last actually the last year, is that there is a great need for a management tool specifically for your gateways. And the reason for this is that you can end up, or we've seen issues where this connectivity, so the connectivity from the gateways to the network server, may not be as stable as you like. And this is not related to LoRa, it's more related to the internet infrastructure that we are, interfacing with. So what you would really need, and what we've seen as a big need for the last couple of months, and now starting to see in larger rollouts, is a gateway management system where you can do management of your gateways. You can do firmware updates of your gateways, and you can basically access the gateways independently of the network server. Say that you want to change the interface to work to other network servers, you can basically go in via a gateway management tool and do this management of your gateways. And this is very powerful, again, if you have more mission critical type of applications, you want to ensure that you can have this access and you can actually do a proper management of your infrastructure. And that's really it when it comes to, in general terms, how we see this market is developing. So what we wanted to do next is basically to show you a couple of real case stories that may fit of general interest for you as listeners, or specifically when it comes to sensitive products. And the first one is actually out of a municipality called Aalborg Kommune. That's Aalborg Municipality in the northern part of Jutland in Denmark. And basically what they wanted to do was that they wanted to collect the data of windows and doors that are open or close. It's that simple. It's probably one of the most simple type of applications, but what they learned was that by getting this data, they would save between 1 and 2 hours of one person per school that would walk around every evening and control the school for open doors and windows prior to closing down the school and turning on the alarm. And then you can make your math yourself. How much money do you save yearly by avoiding 1 to 2 man hours per school per day for this kind of control. But also, which was as important, was that they wanted to have this data into the existing BMS system that they were already using on the school for all the different kind of data that the people controlling the building would need. So not having a separate app just for the doors or windows, not having a different kind of login to get that data, but having everything on the same platform. So what was key was that, with this platform, they could basically take the sensitive strips, and they have now installed more than 200, and install those strips from Sensative in the doors and windows of the school, set up a gateway or 2 gateways per school, which is then a very low cost installation of a complete infrastructure, completely independent of the existing Wi-Fi on the school, get that data to their network server and application server, and convert that, and this was done by a company called NeoGrid, convert that into a cloud solution that directly interfaces to the building BMS, and by that giving the messages. And then if I just go on back, you can see this one. Oops, there's one that is open. So on the existing platform that the people managing the buildings are already using, they now get this additional service. And the only way they could do that is because of Lorawan being open source, so they could take the same data and push that into the existing platform. So as the last slide, basically just to outline the benefits of what happened at Aalborg Municipality for the school installations. They had the requirement to retrofit this open close sensors onto their system and get the data directly into their existing BMS system. Obviously making this wireless, and the solution with LoRa and Lorawan, Lorawan and Sensative strips was a very powerful solution for them to obtain a very low cost for the hardware to be installed, and a very simple installation cost. And then finally, NeoGrid was able to take these LoRa measurements, and less than a second after it was received on the LoRaWAN application server, they could provide the data to the backnet to be able to provide the correct real-time data to the people maintaining the schools. And obviously by using this system, it got fully implemented in the BMS tools already used by the school. So with this, I want to hand over to Patrick, my colleague in Sweden, to talk about specific use cases done in Sweden.
Thank you. For natural reasons, since I'm living in Södertälje, there will be a lot of examples based on activities in Södertälje municipality. So sharing screen. So here you can see some live data from the water temperature where you can swim in the Baltic Sea. And right now it's fairly cold, but so here you have a graph for the last 7 days, and you can select to view last month or the whole month if you want to. This is based on a sensor node device with an external temperature sensor. It is inside a buoy that looks like this. So here you have the sensor, and then the temperature sensor goes down the whole way in this tube and sits about 1 meter below surface. So a closer look to it, there's the sensor and the top end of the buoy. So next example I have is parking places for disabled persons. So this is the center of Södertälje municipality, and the red ones is occupied parkings, and it's also say no here, and the green ones are free to use. So this is live updates as soon as a car is leaving or occupying a parking, it will be shown here. And the reason for this is not only to show where you have free parkings, it's also to get some statistics to find out if you have enough of these parkings, or if you have too many maybe and would like to move one or two. So in order to understand how they are used, this is one of the solutions. Then we have a particle meter measuring the environment, so you can measure particle PM10, PM2.5, PM1. And PM1 is particles that is 1 micrometer large. So they are so small so they can actually penetrate your skin. And PM2.5, as I understand it, can go into the blood system. And PM10 is particles you can get into your lungs, basically. So so here is the latest data, and it goes a lot up and down. So if you want to view this more long term, this is what this particular sensor shown. So right now we are here with slightly higher levels, and in between these high levels is very low. So the average is very good. So all this data is open data. So everything that comes in is also stored in a database. So anyone can do their own website basically and gather the data. And also they integrated this with a chatbot called Kommunkim. So you can ask this one, for example, about parking places. And then it asks, what do you want to know? Is there something wrong with it? And down here you have available parking places. So if you click on it, you get the choice of the parkings for disabled or the other parking. So if we choose the parking for disabled, you get to know which ones are available right now. I pressed 2 times, so here you have them again. And you can also choose all parking places. So if you click on that one, you get this screen we just saw a while back. So a few other examples. I'm not showing live data now, but here is we have sensors in different places that are sensitive to vibrations and movements. So if somebody moves an obstacle just to get into where they shouldn't be, the alarm goes off. And this has been, it's been really, it's been working really good actually. So in the beginning we had a lot of alarms, but lately not so many. Here's another example from Södertälje municipality where they are monitoring the garbage in the garbage cans, and there's also an app tied to it, so you can get every morning the optimum route, and you also get information, which one needs to be emptied. Here's an application with a live buoy, and it doesn't look like this anymore, but just to explain how it works, we can look at this picture. Here you have a sensor and the wire going around the live buoy, and here's a magnet. So every time you take the buoy, the magnet goes off and the alarm goes off as well. And here is a dispenser unit with detergent. As soon as the detergent is about to end, then the alarm goes off and you have enough time to fill it up again, the tank. So that's it for me.